In the worksheet you today, we'll have the theorem on it as well. Alright, so let's look at this. So I think most of you guys have it written down. Don't get finished now. It says any rational root or 0 of a polynomial must be a ratio of a factor of the constant and a factor of the least coefficient. Holy cow, what is it talking about? Let's start breaking this down. What's a rational root? What do you know about this? What are rational numbers? What do you know about rational numbers? Are integers rational numbers? What do you think? Rational numbers. What are irrational numbers? Pi is an example. Why is pi different? It's not just that it's a decimal, it's it doesn't terminate. When a decimal goes on forever. It doesn't repeat, it just goes on forever. Things like square root of 2. That's an irrational number. But rational numbers like 1, 2, 1/2. Anything along those lines, 2.5, 1.3 repeating, because no one's not doing that. Okay, so we're looking at these rational roots. We know roots, or zeros, are just these x-intercepts, right? This is where we plug that number in for x, we get a 0. What we've been dealing with, we did fun of it yesterday. And now we're dealing of a factor of the constant and a factor of the least coefficient. Well, we know we've been writing these in standard form. In standard form, where's our constant in all these forms? And every polynomial, if it's written in standard form, where's our constant? At the end, right? All the way to the right. Let's write that plus c. Okay, no matter what degree the polynomial is, if we have this in standard form, our highest degree is going to be all the way to the left or in the front, however you want to use it. You can just write x to question mark. It can be to any degree. I'll let a be that coefficient. So a is the leading coefficient of this polynomial. This theorem says that any rational root of our polynomial must be a factor of our constant over the factor of our leading coefficient. So any factor of c over any factor of a. Not that easy to see when we just talk about variables. So let's look at number 7. Okay, so I'm going to leave the theorem up on the board though, we can keep relating to it. So looking at our number 7, what's our constant? 6 is perfect. What's our leading coefficient? What are the factors of 6? You can write it this way, but you don't have to. I'm going to just write it for you guys something. With this theorem, we have to be careful. We aren't just looking at positive factors. We know that we can also take -2 times -3 and get 6, don't we? So we need to include that. So we have our factors of 6 are plus or minus 2, plus or minus 3, plus or minus 1, plus or minus 2. Okay, our ones, they have the same deal. Looking back at our theorem, it says, must be a ratio of a factor of the constant and a factor of the leading coefficient. So we're always going to write the factor of the constant first. So any factor we pull from our constant, that's the numerator. And we're just going to create a big list of what possible roots we could have. So first possibility, I'm going to start with 1. So I know I have positive 1 over 1. And I have negative 1 over 1. Well, we said we can multiply by plus or minus 1 to get 1 on the bottom as well. So we really have 1 over 1. We have negative 1 over 1. 1 over negative 1, negative 1 over negative 1. What can we see about these numbers though? What's 1 over 1 equal? What about negative 1 over negative 1? Are these equal the same thing? We don't really need to worry about one of these cases. What about negative 1 over 1? What's that equal? Okay, negative 1. And 1 divided by negative 1? Negative 1. So we can see if we just deal with the negative in our numerator only, we'll get these same possibilities. So we're not even going to bother dealing with plus or minus in our denominator. Okay? That's nice. That gets rid of a lot of stuff for us. It eliminates half the writing. Okay, so I've written 1 over all the factors of 1. Because really now we just have 1. Now I want to do that same thing with 2. So I'll also have 2 over 1 and negative 2 over 1. We also have 3 over 1 and negative 3 over 1. And we have 6 over 1 and negative 6 over 1. And if you want to just write 1, negative 1, 2, negative 2, 3, negative 3, 6, 6, because they're all over 1, that's fine. Okay, everyone see where we got these? All the factors of 6 over all the factors of 1. One's nice because we only have 1 factor. Now why do we bother creating the splits? What do we have here? What's the theorem tell us? But these are the only numbers that can be rational rows for 1. So before, we had no way to factor this. We just could have sat here and guessed the check all day long. Had no direction. Now we know a certain number